Hello again, everybody. Just following up from the last video, now I want to talk about how ring fencing can really go one step above just denying what is bad, but also control what is running. So back to the last point, every time you run something on your computer, every time you open a program, that program has access to everything that you have access to. In our last session, in the last video, we talked about how blocking applications can stop malware, can stop potentially vulnerable software running in your environment. But at the end of the day, sometimes you need to run software. Sometimes you can't block everything. Of course, wouldn't it be great if we could all turn our computers off, turn off the power, unplug the internet, and then we'll get no cyber breaches. But equally, we won't have a machine to use. Just like software, unfortunately, we have to run software on our machines. We run PowerShell, we run Office, we run Windows, we run various applications, and every single one of these applications has the potential to be exploited. So before we go any further, I want to address some of the recent exploits that we've seen that could potentially have been foiled by ring fencing. So I'll go back to November 2019 first. There was a vulnerability in Internet Explorer that allowed any website you visited to run any PowerShell command they wanted on your computer without any interaction from the user. Now, if you just wrap your head around that, we're not talking about a script file, we're not talking about downloading something, we're talking about running a single command, a commandlet inside PowerShell that can potentially turn on BitLocker, upload your files to the internet. And all you had to do was visit a website from Internet Explorer, which I know sounds like a really stupid thing to do anyway, but believe it or not, we see so many people still using Internet Explorer and it's incredibly dangerous. Another vulnerability was Zoom. Of course, at the beginning of the last year, we saw a massive increase in people using Zoom, but also a massive increase in the vulnerabilities. One of those vulnerabilities was it could steal your passwords, but here's the one I'm interested in. You can actually launch PowerShell directly from Zoom. Again, this allows an attacker to launch an attack without any file-based attack, without any running any software on your computer. We've all seen Office documents, macros, and I'm going to dig into them a little bit more today, where an Office document could call a macro that could call PowerShell. This isn't technically a vulnerability because it's a feature that's implemented by design in Microsoft Office. So Office gives you the ability, it's an intended feature that Office can call other applications, and they could be PowerShell, they could be Run DLL, they could be RegServe. There's lots of tools that Office can call. And then finally, I just want to touch on the SolarWinds Orion breach, where there was actually a vulnerability, and this was kind of like a backdoor. It wasn't really a vulnerability because a vulnerability by nature is a feature in code that was not intended to be there. In this case, this was implanted malicious code inside the Orion software that allowed an attacker to launch an attack at a later date. So yes, it wasn't implanted by the vendor, so by true nature it wasn't a backdoor, but it was essentially a backdoor through a compromise inside SolarWinds. Now, the way that worked is essentially the SolarWinds would reach out to the internet, Orion would reach out to the internet and get instruction from an attacker site after a few weeks to, do you want me to do something bad? Do you want me to run malware? Do you want me to delete some files, swap out some scheduled tasks or things like that? So now, given the fact all of these applications are applications that we choose to run, web browsers, applications, Zoom, SolarWinds, these are permitted applications that are added to our whitelist to be able to run. Obviously, blocking them isn't an option, but what we can do is we can limit what they can do. And I want to take PowerShell as an example because PowerShell is the easiest application to demonstrate this with, but technically it's a problem with all applications. I'm going to show you a command here. So I have a PowerShell command here. Essentially what this does is it just runs a loop on my documents folder and uploads all of my files in my documents folder to a Google Cloud. Now, I've ran this on various EDR, various antivirus, and none of them block them. Not to their fault, because that's not what they're intended to do. This isn't malicious software. This is me running a PowerShell command to upload files to the internet. Now, I can call this command from a macro in a Word document. I could potentially call it from a vulnerability in Internet Explorer, from the Zoom vulnerability, where you can open PowerShell, maybe from any kind of vulnerable software. And once it's caught, or even from a rubber ducky, and if you don't know what a rubber ducky is, essentially a rubber ducky, I've got one here with the case off, it's a USB device, and what it allows you to do is you can type keystrokes in the computer when you plug them in, so it will deliver a payload by keyboard strokes rather than by rather than by thingy. So if I literally just plugged it in here, hopefully I capture my keyboard correctly, otherwise I'm going to stop it. And I captured it onto my own computer, so I'm going to cancel that because I don't want my own computer doing that. What it does is it types those keystrokes. It doesn't seem to want to map through to my demo session here, but it types those keystrokes and essentially into run. It opens command prompt, then types them in here, and then hits return. Now what happens in the background there is it literally just uploads all my files to the internet. Now it's not going to be able to do that because I do have ring fencing enabled. So if I go into here and I look for ring fenced, whether I capture these ones or the ones that ran earlier on today, we'll find out. And we'll notice that there's a number of files. You can see here that PowerShell is trying to open all my files in my documents folder, and they were ring fenced because it doesn't have access to it. So here's what we did here essentially. PowerShell needs a lot of power on your system. It needs access to a lot of resources, as does RunDLL and RegServe and CScript and all of these components that are built into Windows. But it doesn't need access to my documents. It doesn't need access to network shares. It doesn't need access to any of my protected files. And if it does need access to a network share, it's probably a limited share that is for scripts or something like that. So what we can do is we can take these applications and we can ring fence them. So we can say, okay, PowerShell can run, but I don't want it to be able to talk to any of my files. I don't want it to be able to go out to the internet, except maybe I do some Office 365 scripting. So I say, okay, it's allowed to go to Office 365. So by doing that, we essentially really limit the amount of damage that PowerShell can do if it's compromised. We don't just do it with PowerShell, we do it with RunDLL, RegServe, any potentially weaponizable application. So that's kind of the first step of ring fencing. Stop it doing things it doesn't need to do, stop it accessing our files, and then it can't do that. The next thing we want to do is take things like Microsoft Office. And Microsoft Office, again, it needs to run on your machine, but it doesn't need to interact with PowerShell. It doesn't need to interact with Command Prompt or CScript or RunDLL. Neither does Adobe Acrobat Reader or Internet Explorer or Google Chrome or Firefox. So what we can do is we can ring fence these applications and we can stop them interacting with applications they shouldn't be able to. What this means is if you do open a piece of malware in a Word document, it's not going to be able to call on PowerShell to execute that command. And very, very simple. And these controls, by the way, if you already use ThreatLocker, you know this, but they're out of the box suggested policies. They're very, very effective at foiling fileless or attacks that exploit vulnerabilities. The other thing you can do, you can integrate this quite nicely with a storage control. So you can say, okay, I've got storage control here, and I don't want anything to be able to access my QuickBooks share other than QuickBooks. So if someone gives you a script or tries to run something on your computer and you allow it through the whitelist, it can't get to those QuickBooks shares. The same with your backup shares. You only need, the only thing that should access your backup share is your backup software. So you can simply create a policy in place to only allow Veeam to access your backup share. And the nice thing about this is everything gets logged. So if an application does go rogue, or even a user goes rogue, you can see everything that happens here. So if someone goes in and decides one day they're going to copy a file to a USB drive, open it, edit it, delete it, you're going to be able to see that in a centralized audit. So I can see, oh, who opened this file? What program did they open it with? What did they do? Oh, this user copied this to their documents folder, but before they copied it to their documents, but they also copied it to a USB drive, which wasn't encrypted. So you can see all of that data logged in a lot of detail. The idea here is by putting more controls around your applications, by putting more controls around your data, by making sure storage devices can't be accessed by applications that aren't trusted, or applications can't step out their lane, and untrusted applications can't run, you're really just taking away the guesswork, you're taking away the hope of cybersecurity, and you're actually putting some control back in your hands as an MSP. Again, if you didn't already book a demo on ThreatLocker, it's 45 minutes. I promise it'll be well worth your time. Just go on to threatlocker.com, click schedule a demo. It's 45 minutes, and we can show you all of this and how it fits in with ThreatLocker Elevation Control and all of the other bits and pieces. But again, thank you for your time and have a good day.